Hello and welcome to the booth of TE Connectivity here at the SPS 2022 in Nuremberg. My name is Michael Steuer. We will talk about sensors, with improved safety and functionality in robots, and the role that sensors play in it. And therefore I have invited Laurent Martel. Welcome.
Thank you, Michael, and I'm glad to be here with you today to speak about sensors and robots.
What is your impression so far from the fair?
So far, I'm very impressed with the fair, also with the TE Connectivity stand, very nice setting, organized in focused applications, and also there is a place you can practice and touch sensors, connectors, and products called the Experience Zone. Very nice, very impressive stand, Michael.
Before we start, give us an introduction what cobots are and what applications they play in.
Cobot means collaborative robots. They are meant to work in proximity with humans and people. They interact with and assist with the workers, whereas a typical industrial robot are designed as a standalone unit with equipment and safety fencing around them. So in the past, this was a concern for the safety and this limited the scope of Cobot application, but now we see more and more acceptance in the market. We're expanding application in medical surgery, electronic manufacturing, also food beverage, and there's more and more integration with AMR, AGVs, with Cobot together.
Where does the safety concerns are coming in, and how does the optimal functionality look like?
Typical industrial robots operates in an environment at high speed and is programmed to perform repetitive tasks. There is barrier and fencing around to prevent any injuries to people and workers. If we remove the safety fencing, then we have more risk, and this is why, to address the safety issue on the cobots, the cobot typically have a lower speed for the arm rotation, and also the sensor are added onto the cobot to limit any and avoid any collision with a human being passing through.
Okay, so we understand that safety is a very important topic. Can you tell us more about it?
Yes, Michael. So there are different norms driving the safety around Cobot. The first one is ISO norm 13849. This is covering the safety of machinery, mechanics and electronics. Another known norm is EN 62061. This is required for the safety level and risk evaluation. What is important is the severity, the frequency, and the possibility of avoiding the hazard. We speak here about safety instrumented function, SIF. Basically, an instrumented function will be a system with an input, which here will be the sensor, with a logic, it will be the processor, and then the output will be the actuator or the actions. There are different category levels in safety for cobots. Commonly known as ISO 13849, category 1, category 2, category 3, and 4. The higher the category number is, the less risk there will be for the cobot to evaluate into its working environment. With the torque sensor, which are embedded in each joint of Cobot, we are able to pass ISO 13849 category 3 performance D or E, which is a great performance together with our OEMs Cobot maker.
So that means to reach the levels, our Cobot customers need to rely on sensors. Can you explain how and what does TE have to support this, and the role that TE is playing in this going forward?
Yes. So one of the most accurate and efficient ways to detect collision is by measuring the torque applied in each joint of the Cobot arm. So you see here an example of a Cobot, the arm, and you see joints. In each of these joints, you have the torque sensor I mentioned here. You can see how it is designed. You got the mechanical part, the electronic for the signal conditioning. And if someone passing through and touches the cobot, it will stop immediately, thanks to the torque measurement in this joint.
So can you explain to us why this torque sensor has been identified as the most reliable sensor in the industry?
I think there are different criteria, reasons why we are so successful in this industry. And I will start, maybe the first most important is people. The ability of our engineering to solve the customer problems. We developed decades of expertise in force sensor, torque sensor, load cell, in the test and measurement industry, then into the aerospace and into the surgical robots. And this was part of building a strong knowledge to be able to communicate and well understand the challenges that the customer are facing. Designing a torque sensor could be seen as quite easy. You put some strain gauges onto a support, but really having a torque sensor which is accurate, not susceptible to cross load, for example, requires a deep understanding of the dynamics of the full system that is a Cobot together. One of the other important aspects after the people is, of course, the technology. We are using a proprietary technology called Microfused. It's a MEM silicon piezoresistive strain gauges which is fused glass bonds onto the metal substrate. It gives a significant advantage for the Cobot safety requirements when you compare that with the traditional bonded foil, because there is no organic epoxies to stick the strain gauges and there's no aging issue with time. The sensor will be repetitive. We have immense experience making millions of sensors using this proven technology for more than 30 years. Finally, there are other advantages about the technology. The fact we use this type of silicon strain gauges, we also use very high performance stainless steel. This gives some superior performance to alternative aluminum substrate, for example, using these applications. The steel has a higher Young modulus, more stiffness than aluminum, and under the same external effort, the substrate will be less deformed. And this, of course, gives a much better response for the sensor and a better accuracy.
Where do you envision PE to be in a couple of years from now? Is there other applications in robotics that will have a higher demand in sensors?
If we look at the Cobot, what we are looking now is to combine different sensing technology together, to fuse them, to offer more output out of the system. It could be torque and position together, for example. Also, we are looking at expanding the size and the load range on the torque sensor to cope with new Cobot and higher payload used by our customers. We just developed a new eddy current encoder. We are early stage, but we have excellent results. The sensor will be able to provide a 16-19-bit resolution. And our first test result in the laboratory gave us an accuracy of 0.05 degree, which will bring really a strong value to the full system torque and position inside each joint. There are other applications in the end effector, load cell, haptics feedback. We are investigating. Also, we play a key role in surgical robotics for the end effector, for example, in stapling tools. And finally, Cobot is not only the only type of robot in the industry growing. We all heard about AMRs, autonomous mobile robot, AGVs, autonomous guided robots. And we have some key sensors playing a role there. For example, a very small load cell can be put on each AMR robot to measure the weight that the AMR will carry over. We have here a next generation wireless 3-axis vibration sensors that will detect anomalies on rotating assets before they happen. The field is called Predictive Maintenance and condition-based monitoring. We use inside our proprietary technology based on piezoelectric vibration monitoring.
Is there any key takeaway that you would give to the audience here out of this discussion?
Yes, Michael. So, thanks again for all this Very good question. In our sensor business unit, we got more than 700 engineers fully dedicated to the design and the manufacturing of sensors. We design products from die-level ASIC design to board mount sensors to application-specific module up to the wireless solution, which is our latest development for the condition monitoring and predictive maintenance. And to speak a bit more about our capabilities in sensor, we make and design position sensor, temperature, force, speed, humidity, torque, vibration, and many others. And altogether, we have more than 30 different sensing technology, which will help customers to pick with us the best solution to solve their problems.
Thank you very much for being here and answering all those questions. And I think we can agree that TE does have technology to enable a safer and sustainable future in alignment with our corporate responsibility. Thank you very much and enjoy the day on the SPS. Thanks.
Thank you, Michael.